We're always tending to look at our own solutions. And secondly, I'm going to start with a very coarse-grained view, like from a geostationary satellite. Everything else in agriculture disappears for me where ICT is concerned. I see only one problem. The problem is there is a lot of scientific knowledge being created, validated in many places across India, across the world. But we know for a fact that the gap is becoming wider between farm families and these processes of creation validation. Second, a very big problem that is very particular to India, also to a few other countries, is that very important credit and insurance agencies and farmers are still not able to bridge the gap. And these two, in my view, tend to contribute to a host of other gaps. And we will take a look at a very short case study before concluding with a few more perspective statements. One is my colleague, Dr. V.P. Sharma, who is a specialist in extension management, will agree with me that traditional extension systems were doing a very good job of filling this gap. They were conveying scientific information from laboratories or field stations into the farms quite regularly, consistently, with a high degree of accuracy. They were doing that job. But we must accept that today they are in a state of disarray in many countries, not just in India. Of course, there are examples like Ethiopia where the opposite is happening, where the extension system is actually getting better and better in public sector. And generally, the OECD impression, expatriates and my colleagues who come from OECD countries always say that why should you be worried about public sector extension anymore? Why not privatize it? I mean, like India, at least peninsular India, healthcare is by and large privatized. I mean, if you have money, you have access to Medicare. Why can't we go that route? Well, I mean, we know that, all of us know that this is not an easy task for a very large country. There are a lot of advances. I particularly note soil and water management in the context of drought in India today and in many other parts of the world. But these advances are not readily available to the farmers. We know that for a fact. I always look at two streams in India where IT for development is proceeded in a big way. In fact, eIndia is an example of that. It didn't exist, say, 5 years back or probably 6 years back, but it has become a major event in India now, and thanks largely to the investments that take place in ICT 40, where it's a general purpose rural development, and you always start from the village and move towards the institutions from there. I mean, a lot of village knowledge centers have been set up. The number one time was in excess of 10,000, slightly smaller now in India. And Government of India has very large plans and is already active in promoting close to 100,000 such centers, very well organized and very well equipped. On the other hand, we also have, like we have Dr. Trivedi and we have many representatives from the senior representatives from the state agriculture universities, ICA, who know that they have been investing a lot. We just heard one presentation from Darwin. They have been investing a lot in the area of applying IT and improving IT skills. Of course, the fact is that not just in India, again taking a larger view, you find that agriculture community, especially research development education community, has not been as savvy in deploying and using ICT the way many other development sectors would be, like medical profession, for example, public health. I always give this example that some of you may have heard it and may already be feeling tired. I asked Srivatsan what is the number of agriculture-related articles in Wikipedia in English, which has 2 million articles. When my students did a lot of census, they could not locate more than 6,000. And we compared it with certain interesting things, like there is a very big article which describes how Boeing 777's cockpit is nothing other than Boeing 767's cockpit, and there is an article on how Boeing engineers junction two completely different designs. It's a brilliant article. It's a major piece of engineering achievement. But we don't have one on hybrid rice, which is apparently as complex a job as what Boeing did. But there's not even one. And water, even less. So there is a bias, and this bias, I believe, is creating a big vacuum. The digital content in agriculture is not sufficient to support a lot of efforts that can take place in the area of IT for development. This is again a perspective statement. I mean, we can debate about that. The volume is just not adequate to build services. Okay. And that, therefore, if you look at Indian experience, I'm relying primarily here on a series of studies carried out by the IIIT in Bangalore. This study was headed by Professor Patsarathi Balaji and Professor Kenneth Keniston from MIT. And they pointed out that there is a lot of top-downness in some of these approaches, of course, But they pointed out that out of 144 that they surveyed in 2006, ICT for Deep projects in India, less than half a dozen had anything to do with production agriculture. You know, some of us work in agriculture institutes. We don't think that market price offering is not a great deal of a job. I mean, it's fine, very important, you're filling a gap. But you must talk about production, either input production or crop production or animal production. If you're not supporting that, we don't consider you as contributing to agriculture. Or we must also talk about mitigation efforts, because floods occur, drought occurs. It's a very critical ones. And secondly, you know, suddenly there is a realization that the old type of PC-centric approaches might not, after all, be the most viable ones. They may have to be supplemented. They may have to be even replaced in some cases with call centers, mobile telephony-based approaches. So I'm not going into the details. So one of the programs we came out with was that after an analysis of a number of these things, we came out with the idea that probably we should think of a new knowledge system for food security, a model which includes IT for development, which includes creation of digital content from a very vast, a wide range of resources, from national, international resources, as well as extra institutional resources. Because, you know, agriculture system is relatively resistant to accepting information from non-institutional resources, because we are structured like a public health agency. You have to have certain standing before you can contribute valid information. It's not so in the case of many engineering practices, because of which practitioners can directly influence the course of engineering development. It can't be the case in agriculture. You have to go through the system. But a time comes when you need to accept it. Dr. Runa Sarkar, who's here, whose work on Agropedia is very remarkable, because it accepts people's science, I mean popular contributions, at a non-certified level in their portal. What is also important is the continuing improvement of open and distance learning. Our panel chair himself represents one of the mega universities of the world, the IGNO, and there are colleagues from Thailand here who represent the open university system of Thailand. This is a rapidly maturing paradigm and offers us unprecedented opportunities for experts to be able to engage with people who have been outside the classroom milieu for a long time. And these methods have suddenly matured enough to say that they should now be offering opportunities for mass education in agriculture and elsewhere. And I won't go into a case study except to show that in a very small area, Dr. Baga knows we are working in Mahbub Nagar, which is about 120 kilometers from here. We've been working with a relatively impoverished community, a women's group. What we did was, can all this make a difference to them? A simple study. We've been doing that for 3 years. And what we do is, every year as the season begins in India, in May, when the IMD, the Indian Met Department, comes out with broad predictions. I have 3 more minutes. Is that okay? We took charge of that and analyzed what would be the implications for a cluster of just 21 villages. And we also looked at a completely different international forecast from Columbia University, from the IRI. There are slight differences, but all of them by and large said that there would be a drought in large part of India, especially over peninsular India. And therefore we calculated that the rainfall in that area would be less than normal, and we projected a scenario, came out with first broad-based recommendations. And we encourage the women there who work with us in this ICT for Development program to set up rain gauges, which are very simple. I mean, they cost about $25 to $30 in international sense, but certified by agencies. And you can see they are able to load them regularly on a wiki page. And so it gives us a consistency. If there are misreadings, you can still detect one from the other. You can also automate that. You can see that in this area, the actual rainfall up to August 23rd from 1st June has just been 116 millimeter. It's still lower than the worst scenario we assumed. And what it results in is that we were able to project it as a very simple map based on satellite imagery and a lot of ground truthing. We arrived at a water balance model, which projects how many villages here would be highly vulnerable. And we projected this by end of May to tell them that at least 6 out of 21 will go through very severe drought. They will have even drinking water problems. And a number of others would still have problems of a different kind. And we also looked at more optimistic scenarios which we knew would not happen. And this was very widely shared with the people there. I mean, many of them were able to understand the color codes. We've been doing this over 3 years. In fact, Dr. Baga knows we even published an IEEE conference peer-reviewed paper on it. The method is fairly standardized with the help of IIT in Bombay. Now what we find is that we are able to give advisories that people can respond to now. They know where the gaps exist in government programs. Earlier they all thought that it's a narrow phenomenon and government isn't helping by sending water. Now they know that it's a bigger phenomenon. They ask government for more meaningful intermediation. So now coming to the end of my talk, what I therefore believe is, when we look at ICT opportunities for extension or even education, these areas are very important. Crop scientists tend to dominate this area and they want only crop information, which is rather unfortunate. We must start with actually soil health and water and then go into plant protection. I hope Dr. Trivedi is not a plant scientist. I mean, there's no criticism of plant breeders, but this is always the perspective in a country like India. Disaster prevention in a region like South Asia must be at the root of all ICT for the efforts, because the South Asia region as a whole is one of the most disaster-prone regions of the world. Cyclones, landslides, earthquakes, drought, you have everything here, sometimes all together. And therefore, I believe we should have very simple interventions that bring ICT for development and ICT for agriculture closer. One is there are major advances in soil health monitoring using remote methods. We should be able to bring them closer so you can generate maps that give you even micronutrient distribution. And wider use of sensor networks in relation to water is a must. We must have at least a few hundred field stations where sensor networks are deployed from where real-time information is collected for modeling. And credit insurance, this is something very opaque. I mean, we know that there are banks which collect real-time information on weather from several hundred locations in India for rainfall insurance. They don't share the data with others. Why not? Okay, so now we have a small program. I won't go into that except to say that it's time for us to think of coming together to imagine a large, grand organization. And we have support of NAIP, like what Dr. Trivedi has and many others here will have, trying to bring together a variety of resources to create a large content management, not content system. The Agropedia, as we call it, has features that include very advanced generation. And thanks to Dr. Srivatsan and Ajit here, we are also imagined use of multimodal delivery. We are looking at village knowledge centers, TV, radio, as well as call centers. And you'll find that there is considerable progress going on, and thanks to the help of IIIT in Kerala, we are able to use the Open Web GIS as well. Coming to the end of it all, what we believe is that India as a large country has a unique problem. That we have less than 200,000, am I right? 200,000 workers in the entire area of extension. Even less, including PhD level people. And we have 220 million farmers to deal with. So it's a very unique situation. So certain amount of virtualization is a must, and we must accept that para-professionals will have to come into existence. Now an organization like IGNO and ICR probably can come together to design altogether new paradigms by which we create these para-professional workers, virtualize regular experts, so that hundreds of millions of farmers can be served. Thank you for the opportunity.